Michael, thank you for making some time.
Yeah, no, thank you very much for having me on. I'm really excited to, finally chat.
Yeah, absolutely, absolutely. Well, so first things first. Tell us so honestly, the first question is very straightforward. Where did you grow up and what was the night sky like where that was?
So I grew up kind of in, I don't know how you describe it, maybe suburbs in Massachusetts. I'm originally from kind of the Boston area, outside, maybe an hour outside of Boston. And um in terms of the night sky, I mean, around there was actually relatively clear, I guess. There's not much, not too much impeding, but I guess really as a kid, I didn't really look up that much at the sky as much. I do space stuff now, and I'm really involved in the industry, but a lot of that happened very, very recently, just in the past few years of my own kind of volition.
Really? Really? So it wasn't like what was interest to you if not the night sky? Were you playing a lot of sports? Were you doing other science stuff?
Definitely still a lot of science and technology stuff. So even as a little kid, I always loved, like the space books and everything, black holes and everything. There's always the coolest thing as a kid and look at the planets and everything. And the space, I think, has always been, at least growing up with those, books and stuff and those interests and having that interest in general science, I think, still was a foundation to, growing to what I do now. So there's always that seed of interest in science and engineering and just making things.
Well, so in that case then, so because you start, not really, obsessed with space, but you got the books and things like what was that path from just like, oh yeah, all kids like black holes or all kids like, the meteors, etc., to what you're doing now? What was that kind of journey like?
Um, so I guess, like I said, in terms of my space efforts, that's very, very recent and things have moved pretty rapidly. But I guess, kind of progressing from there, my first real introduction into science and technology was really robotics. About fifth grade, my parents signed me up for a Lego robotics camp. And that's where I really got that exposure to like the science and engineering, and I absolutely loved it. I had a blast with that. And I started getting into Lego Mindstorms and everything, and that's really what started kicking off getting into, the engineering and science. And over the years, through middle school, it was always robotics and everything. I joined the high school robotics team afterwards, and always loved building and tinkering with electronics and circuits and everything myself. And then actually probably in high school around ninth grade, we had to do a book report and we had to pick some scientist or just famous person. They had all these books laid out and we had to pick one and do a report on them. And I was the last to pick because they were doing reverse alphabetical order for the names. And my last name is Bretti, so I was the last to pick. And the last book on the table was Nikola Tesla. And I had no idea who he was. He sounded like he had a really cool name. So I kind of just went with that. And then I found out, he did some really awesome stuff with high voltage. And that's what got me, really excited, starting to pivot away from the robotics type of stuff more into high voltage things. So playing around with high voltage generators and, spark ignition coils and things like that, and making a lot of ozone. And my parents, telling me don't burn the house down and things like that all the time. And then really from the high voltage type stuff through college, I continued to get more interested in plasma systems and particle beams type physics and things like that. Um, and also kind of in high school as well, another interest of mine was also um, the do-it-yourself jet engines with like the turbochargers. People converting car turbochargers into the turbines, and then do-it-yourself pulse jets. Those things were always really cool to look at, and I never had the resources really to play with that stuff because they needed welding, and I didn't have welding equipment then. But looking online, it was always really fascinating to see people building these jet turbines and everything in their garage. And I did dabble a little bit with hybrid rocketry. So I went to Home Depot and I got the pipe fittings and I cast my own fuel bores and I had the little oxygen tank that I lit and was kind of playing with that. So that was kind of my first foray into propulsion stuff. But then fast forwarding over the years, getting more and more involved and interested in the high voltage physics and stuff like that. Eventually things kind of just came together with the propulsion stuff that I do now. I work on electric propulsion, which is plasma and ion thrusters. So um, I found, after this was much later after I graduated from college and I was just still doing stuff on my own. I'd always wanted to get involved in doing more plasma type experiments. And you can do them at atmosphere, you can do them in vacuum, you can do a whole bunch of different stuff. So I decided to, save up a little bit of money and do some eBay shopping and design out and purchase out a vacuum chamber. And originally I was going to do particle beam type stuff. And there's some issues with that at the energies I was looking at, really high voltages. There's a lot of X-rays that can be produced at the power levels that I was looking to do, because I had a lot of experience at that point with high power pulse systems and high voltages, and there's some safety stuff involved. So I was thinking, what's something safer that I can play with that I don't have to, buy a lot of lead shielding for? And I've always been fascinated with the plasma stuff, and I was like, you know what? Plasma thrusters are pretty cool. They're high voltage, they're propulsion. I love both of that stuff. So taking the high voltage hobby and my interest in like the pulse jets and the do-it-yourself turbine stuff, and combining it into one thing, using electricity to create plasma to create thrust. And I just started from there. My first thrusters. I just started playing around with just some really basic designs, no idea what I was doing at all. And I started posting about it. I created an account on Twitter and started posting, and people started seeing over time, and eventually it got the attention of people in the Pocket Cube and CubeSat communities. And that's the point where I really started focusing more into the space type things, is being introduced now into that, do it yourself, because there's a lot of people then at that point. I think this was in, I started building my vacuum system in 2018 and started playing around with my verse thrusters in the beginning of 2019. And at that point, there was already a lot of amateur do-it-yourself satellite groups and stuff, like Fossa Systems being one, for the Pocket Cubes. So getting kind of introduced into that community through social media, I kind of found this niche, developing these systems for those groups and working with them more closely. And that's kind of where my propulsion stuff kind of took off. So very, very recent, 2019, I officially started doing propulsion stuff myself and really but that was really when I really pivoted into the space industry, I guess, myself, just kind of from the hobby and just getting involved with these groups and just chatting with people, doing some really cool projects all over the world. And it's kind of drawn me into the point where, I'm here for the long haul.
Here for the long haul, here for the long haul. Well, I mean, I just find it so fascinating. So what is it, a specific thing about propulsion that just like, all right, you love the mobility aspect, or just the physics problems that you're tackling, or
I think it's hard to describe, because I can't even describe why I like the high voltage and the plasma stuff itself. Is just, I just find it so just intrinsically so fascinating that you can manipulate and control this like raw energy to do stuff that you want. And what's really cool about propulsion is you're taking plasma and ion beams and these different states of matter, and being able to um, do something very useful with them. Because in high school, when I was playing around with the high voltage, I was making sparks and stuff and seeing how long I can make the sparks. And after a while, it's like, that's cool, that's fun, but I want to do something really useful with this high voltage, with this plasma, something that actually does something more meaningful than just making arcs. And I think one thing that I really like about the electric propulsion is, you're manipulating these plasmas and these ion beams and everything to essentially do something very useful. And it's also really cool that you can strap them onto something and push things around and use that force generated from these plasmas and things to move stuff. And because there's lots of industrial processes that use plasma. There's semiconductors, there's sputtering, there's other types of processes and things. And one of the things I like about, the propulsion and the micropropulsion stuff is, um, you can make these systems really small. They're not really big industrial systems. You can have, a little plasma thruster, fully functional with all the electronics of the thruster and everything that sits in the palm of your hand. And I think I also like that aspect of where, you know, everything is contained in this tiny little unit, and you can do all of that really cool physics, very, very simply. And you don't really need even like these big power supplies, or things to actually do these things that actually move stuff.
Excellent, excellent. So I'm curious then, where do you see your work going from here? Because you mentioned like your basement is your workshop. So are you
Yep.
planning on like, because a lot of people are like, all right, they solve the problem that they want in an open source way and it gets it out into the universe, but they don't have any interest in like, building a company or building, larger scale systems. Are you having this be purely like, as you mentioned, kind of like the CubeSat or PocketSat level, or you have grand, like, larger aspirations for larger engines? Or tell a little bit more. Where do you see the future of your work?
Yeah, so again, it really started just, a hobby, and it's still technically a hobby, but I guess at this point it's really involved hobby now. And when I first started, I had absolutely no intention of, starting up a company or anything, or I had no idea what I was doing. It's even to begin with. I was just, screwing around and seeing what happened. And things kind of just snowballed from there. I first started posting the stuff and, gaining more traction and meeting more people in the community, and then starting to talk to people. There's a real interest at these levels for propulsion that was really cheap and accessible. Because if you look at kind of the micro propulsion industry now and how it's emerging, there's so many startups all over the world. Everyone's doing all these technologies and everything. And, propulsion has come down in size and cost from the kind of the older days, where this stuff was all NASA level, multi-million dollar engines that are on really big satellites. Now you can still get, full systems for pocket cubes and larger stuff, much cheaper being, $50,000, several $100,000. And for a lot of these CubeSat and Pocket Cube groups, that's a launch cost. That's the cost of their entire satellite. So what I've been working with specifically, is developing really low cost, very simple to access and to use types of propulsion systems. So that's all been kind of done, just as a hobby in the basement on the side. And as I've continued to advance my experience and figure out new ways to do stuff myself and expanding into different technologies, things have kind of naturally grown and progressed, and I've gotten involved in more complex thrusters, more um and larger scale stuff. Um so I had no intention of really getting any farther besides just, posting simple stuff. And then now it's kind of grown. AIS now is an official, company. I am, working with lots of people around the world doing stuff. I'm still all on my side of my all on the side of my free time, but it's become a much more serious effort. And I have been recently rapidly expanding out a lot of my systems. So at the core, I still do a lot of support and development, and primarily working at down to the Pocket Cube level. That's because that's where I really started, and that's, the community that brought me into the space. And there's still not really any options or anyone really working on this stuff at that scale that much. So I've been spearheading a lot of different technologies for that. And one nice thing about the Pocket Cube scale is it's both easy and difficult, because the thrusters are very small, so it's very cheap and simple to prototype, but it's very difficult to get good performance. But if you can get something working well at that level, and for people who don't know, Pocket Cube is 5 by 5 by 5 centimeters for the whole satellite. So getting a thruster to fit inside that cube is really, really, really difficult. So if you can get something actually working at that level, if you start scaling up to CubeSat scale thrusters and even larger scale thrusters, um, at least for me, the way I develop, I find it becomes much easier, because you're going from like this tiny cramped box to a huge warehouse in size. So you have a lot more power, you have a lot more space, and it becomes easier for me to scale. So I actually have recently been scaling up my thruster systems, and now I'm officially covering the range of everything from pocket cube to about 6U CubeSat. But I have been dabbling in higher power stuff. I've run one of my vacuum arc thrusters, like, for example, at 200 watts, which is getting up there in reasonable medium level power levels. I haven't released it yet, but probably over the next few days, I will be showing a look at my first adamantane fueled arc jet thruster. So this is now getting into some higher power levels. So we'll see how much I can reasonably run it before things catch fire. But I'm looking to, you hit hundreds of watts, maybe a kilowatt of power for that thruster system. Um, and still, focusing on really small scale stuff. So I am looking to eventually, expand across the board, all different types of thruster technologies, all different power levels, all different sizes, because I think if you can do it at the really small scale, going up larger becomes much easier. And most companies and people who develop propulsion, they focus on one type of propulsion system, and um, there's no one good solution for every use case. Each technology has strengths and weaknesses. And I think being able to explore all different types of propulsion technologies, for one, it's super fun because there's so much to explore and you can't ever get bored of it. But two, it also allows you to cover a lot of different use cases. There's a group that might really want this one type of thruster, for example, that works well, that really can't work it well at all for another group. So I like having that option to be able to give to a whole range of people, and then kind of getting into like the really high power, more competitive commercial scene at the larger scale. I think I can leverage my development philosophy and how I've designed these systems to be relatively low cost and still scale it up to that level to, if anything, shake things up and maybe get people nervous. But it's still all been a lot of fun. And at the end of the day, um, you know, it's for me, it's all just about, just playing around with this stuff and just seeing what happens.
Seeing what happens, absolutely. I mean, so you mentioned like you getting intro to this community, this broader like global open source community and development and all that kind of stuff. So are you reaching out to like specific experts, or you're just saying, all right, I've got this problem that I'm working at, and you tap the diaspora and say, hey, can someone help me out with this?
Yeah,
Like,
well,
how are people
actually,
getting involved in AIS?
really what's happened is that because of the way that I've approached things and developed propulsion and do it, completely openly, and engage people on a really personal level for these propulsion developments, people have really just I've kind of just crapped everything out there into onto the web, and then people see it, and then they end up coming to me, and just, I've done a lot of mentorship. Actually, just before this meeting, I had a talk with another um, student Pocket Cube group in Romania, discussing propulsion stuff with them. Had another chat with another um, student group yesterday in the US about propulsion as well. They're doing both Pocket Cube and CubeSat stuff too. So I think because of the way that I've approached development, and I kind of have really openly shared what I've done, um, people have kind of seen it and kind of just sought me out, just to ask about this stuff. And I'm always, a lot of AIS is, it's more than just, developing a propulsion product and selling it, and that's the end of it. It's really very heavy engagement with, students, with the amateur and hobbyist groups, and providing resources about this technology. Because if you think of a plasma thruster or an ion thruster, even if you read stuff from NASA about it, for example, like an article, it's going to be spun in a way that sounds very sci-fi, very futuristic. This is the state of the art, and this stuff is not. And actually, I have examples here that kind of to show you.
Yeah, 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 absolutely.
So this was the first thruster I ever got firing. It worked for one single shot. And I broke a ton of equipment to get this firing just once. But that was kind of the point of where I transitioned from seeing, maybe this is actually possible. So this is the thruster. It's literally just plates of Teflon and copper bolted together. That's it. And I had a high voltage pulsar from the outside, and I was just feeding high voltage into the chamber and pulsing it. But this is essentially the whole thruster. And over time, it ended up, changing. So I shrunk it down to now pocket cube size. And then this was the first full module I ever built for pocket cubes. And this is actually fully open source. You can actually go on the website. You can download the entire files and everything to see, how it's built. But this is, the entire electronics, the propulsion unit and everything. And essentially, it's a pulse plasma thruster, and essentially it's literally just like a flash camera circuit. I have literally a flash camera trigger coil here, and a little high voltage supply, and then again, this thruster is nothing more than Teflon and copper plates bolted together. And that will make you plasma in vacuum. So a lot of stuff that I want to show people and bring, to the community in all these other groups and stuff is that at the end of the day, propulsion systems, especially electric propulsion, doesn't matter if it's a Hall thruster or gridded ion thruster or pulse plasma thruster. The principles can be broken down to very simple things, and you can read papers, you can read the theory, you can see, the diagrams and stuff. But a lot of times, the actual physical, tangible aspect of those systems kind of get lost, and it might be difficult to go from that concept to something in reality. So what I've worked on a lot is showing people, these thrusters can be really, really simple. They can just be a few plates bolted together, and you're putting some high voltage on them, and that's your thruster. Um, so that's a lot of what I've kind of done, and that's kind of put me in a position, especially since I've been so open with my development, in just being able to engage people from all over the world interested in propulsion systems, whether they're a PhD student or a high school student, and kind of open those doors.
That's incredible. That's incredible. So how have you sorry. Late nights. I'll try and edit that out if I can. Um, anyway, so you're talking with these students. How are you like, what is it like to see these people who are just like getting started start to like see your work and understand your work and kind of start to build onto it? These you mentioned like high school groups all over the world. Like what is that like for you who's been kind of tinkering away at this?
Yeah, well, in terms of the propulsion aspect, a lot of them are actually developing the satellites. So they come to me
Mm.
um, asking about the propulsion and what I do, and if it's possible to use my propulsion on the stuff. So we haven't gotten to the point yet of where people are doing propulsion themselves yet that much at home, but there's definitely a lot of interest. And I have already, I've met a couple of people who one guy last week or this past week, was discussing starting up his own propulsion company. I've talked with a very bright young man. I think he was 15, globally, who started, designing his own thruster systems as well after seeing my stuff on Twitter. So I think those seeds are there, and I think there's certain barriers that can be broken down that once you get over them becomes more accessible. One of those is the vacuum. Typically, electric propulsion systems, you need some sort of vacuum to run them effectively. If you fire them in there, they just don't work. And a big barrier I hear a lot, especially for students, is they want to get involved in this stuff, but it's the vacuum system that's a challenge. So I've spoken with them on how they could do vacuum stuff relatively cheaper. And when I first started out, I bought a really cheap refrigeration pump on eBay. I got a simple oil diffusion pump and some basic small chamber parts to put that together. I'm fortunate in the U.S. we have a huge surplus market for vacuum, so it's much easier if you're in the U.S. to get involved in this stuff than maybe other parts of the world. Um, but that's a big challenge getting involved with propulsion development, is the vacuum side. But there's a lot of but even on the space side, it's always really exciting to see all these student groups and stuff, getting involved in building these satellites and doing these missions. And I know I've been recently talking with another group that they started a undergraduate electric propulsion club. So
Nice.
they are actively, doing the stuff, and I actually sent them one of the kits that I've developed. So to kind of address this problem of, people are really interested in doing this stuff, but it can be difficult to know where to start. How do you design a thruster completely from scratch? So I've worked to kind of address this problem. I've kind of worked on developing really low cost do-it-yourself electric propulsion kits. So I've already sent out a bunch of them around the world to different people everywhere from another propulsion company looking to get into electric propulsion to these student groups to other hobbyists doing stuff at home. And that's kind of been my starting push in getting more people in the do-it-yourself community involved with electric propulsion, is these kind of really small kits that are based off of the actual orbital systems. And I can actually show
Yeah, yeah, yeah.
kind of just an idea of what like the stuff actually looks like. So this is kind of that kit thruster. So very,
Yeah.
very simple. There's only a few electrical components. The thruster, again, you have a copper piece, you have a 3D printed housing, you have little, a few other off-the-shelf hardware parts you can get from McMaster-Carr, Oshpark board, the nice purple PCBs. And this has kind of been that first push into fully do-it-yourself propulsion. So, I have the complete user manual that walks you through the entire build process, the debugging, troubleshooting, testing. And for this particular thruster, I selected a technology that can be run at really poor vacuum. So different propulsion systems can be run at different vacuum levels. And this one is a metal arc thruster, and this can actually be run at pretty crappy vacuum. So that really opens up, people can buy a really cheap degassing chamber on Amazon for like $150, $200. It'll have really, really horrible vacuum, but the vacuum is good enough that you can actually fire something like this. So designing these things in a way that can be um, done with much more crude vacuum setups as well. And then, if people get, down the road, expand more into it, then they can always upgrade and get into more advanced stuff along the way. But at least providing that initial seed to start with.
So, I mean, we're talking about propulsion systems, it's that idea of being able to, get what you want where you need it, right? I'm curious about, as we're in kind of the middle of this kind of second space race, what are your thoughts on kind of like how do you see this kind of push? I mean, your systems aren't going to be, landing on or like orbiting Neptune anytime soon. But
Yeah,
what are your thoughts on like how we're kind of like starting to step out into the cosmos?
yeah. So I think there's definitely a lot of excitement, and especially like I said, there's tons and tons of propulsion startups popping up all over all the time now. There's a lot of interest and funding going into propulsion. Um, And I think, there's also even, these regulations now, the satellites have to deorbit within 5 years. And there's even talks, eventually they might, require satellites, or at least certain satellites, to have propulsion on board for collision avoidance as things get more crowded up there. So there's definitely more and more interest and needs. And even in general, with more and more CubeSats going up, with now lots of pocket cubes going up with recent launches and launch costs going down, I think it's a lot more just accessible in general for people to be able to start integrating these propulsion systems on their satellites, because the satellites are coming down in cost. And eventually, not right now, the propulsion systems are pretty expensive, but kind of what I've been working on, and maybe over time, um, propulsion might get down cheaper for more people to access them. But I think there's also a lot of issues that have to be addressed in the field, especially with expectation and hype, because I think there's there's a lot of issues, at least coming from my perspective, in really open development. There's a lot of transparency issues in the field. There's a lot of challenges with representation of actual performance versus hypothetical performance. And I think that creates a lot of unrealistic expectations of what certain technologies can or can't do. And I think there's just a lot of just issues in general with, the stuff is being super hyped up as, it's the answer to everything. And, I build propulsion. I'd love to sell, more propulsion and get, these things, to people all around the world. But at the same time, I also like to acknowledge that, not every satellite needs propulsion. And propulsion isn't necessary for every mission. And I know, if you talk to someone in the propulsion field developing these thrusters and you say, what do you think about, the requirements of having a satellite have propulsion, they're going to tell you, you're like, oh, yes, absolutely. They all need propulsion. But, talking with these groups at a more personal level, adding propulsion to a satellite isn't just slapping a thruster on and that's it. If you have a thruster, then you're going to need a way to point your satellite in the right direction. So that way, as you're firing up instead of down back into the Earth and deorbiting before you'd really like to. So that means you have to have some sort of ADCS involved. So that adds another subsystem complexity, that adds control and integration complexities as well. And it makes, your simple, if you're doing a 1U CubeSat and you're being, or even a pocket cube, and you're now being forced to put propulsion on that system, well, that means you also need a reaction wheel system. That means you need more advanced controls. And, if groups are eventually forced to have this stuff, then there's a possibility that, if the options aren't available, then a lot of people might not be able to fly because one, it's difficult to cram everything, your payload, a camera payload or communications and propulsion and everything else, now a reaction wheel system to point in smaller satellites. But for a lot of cases, the propulsion is not really strictly necessary for what people want to do. A lot of times for a lot of these smaller satellites, it's perfectly fine just floating up there, capturing images, doing what they want. And you don't necessarily need to do, big maneuvers. And for collision avoidance stuff, it's nice to be able to move out of the way and avoid things. But for the most part, there a lot of these smaller groups and stuff might not necessarily need propulsion. So I've always been kind of a proponent of letting the groups, evolve their capabilities and, have their capabilities set down and advanced enough that way that when propulsion is required, they're ready to begin transitioning into it rather than just forcing it to happen on all the satellites and making it work that way. Because at the smaller scale, you're also kind of limited in what you can do. You're limited in size, you're limited in power. So realistically, how much movement you can actually get can be a challenge. And propulsion, you might think, oh, you're going to move, tens of kilometers or hundreds of kilometers with this tiny thruster, where in reality, you might move maybe a few hundred meters or stuff at most. So there's always kind of that aspect of balancing out what your needs are and what realistically is necessary.
Excellent, excellent. Yeah, and that whole idea of, we have these legitimate concerns about, debris and all this kind of stuff, but
Yeah, and it's definitely a concern. Yeah.
but how do we balance that? So yeah, I mean, so going through, well, I should ask, are you still based in the Northeast?
Yep, I'm still located in upstate New York.
Okay.
I'll be here for the foreseeable future at this point.
Well, so I mean, my final question, but I do want to make sure that we get all the links to not only your work, but also if people want kits and things like that, I want to make sure we get all those links, and we'll grab that after this. My final question is, has your like in upstate New York, like has your relationship with space kind of changed? Obviously professionally, but has your relationship kind of personally changed now that you're looking up and you're like, oh, you're gonna have hardware up there at some point, what is has there
Yeah,
been an
no,
evolution or?
yeah, no, I think now I definitely pay a lot more attention, and I actually have gotten stuff up there already as well. My first thruster flew on a 1U CubeSat, I think in 2001, and that was really surreal seeing the live stream of the rocket go up and the deployment. I think that was on a Rocket Lab Electron rocket. Um, so that really changed my perspective. Before, like at the beginning when I said, I didn't really pay too much attention to, looking up the stars or anything. But now, you know, having something actually up there that I've built literally, you know, in this room and tested in the basement, with, dirty laundry on the side over here and parts over here. It kind of brings it into a new perspective that it's like, I don't know, it's really cool to, have something out there, and the opportunity to have more things out there and really contribute to the development of this field, as a whole, in a unique way that, I don't have venture capital funding. I don't have funding from, any. I'm not a startup from a university. It's just doing this on the side in my free time. And I think, if you really pursue it and you're really interested in it, I think now with the resources that are available, more people can have that opportunity to, you know, get something up there.
That is awesome. That is awesome. The yeah, that whole idea of, you know, having that sense of like, oh wow, something you've built is right up there, something you was within proximity of dirty laundry and dishes and all the kind of stuff, is that connection to the cosmos. So I'm kind of curious then. My final question is, do you have advice for people who are perhaps where you were, years ago? They have a vague interest, but they have no idea where to start. Is it reaching out to you on Twitter? Is it, just going down like YouTube rabbit holes? Or like what would be your suggestion to someone who is interested, but they're
Yeah,
looking for that first step?
yeah, and that's a question I get a lot all the time from a lot of people is, how do I start, um, you know, doing things? And for me, the way I just always started was, I found just pick something that interests you, anything. If you're interested in, electronics or mechanical, or it doesn't matter, just pick something. It doesn't have to be complex or anything, and just start tinkering with it. Things don't have to work, and they usually don't work. And I've had, if you followed my stuff on Twitter and stuff, you've seen that I've had more failures than successes, and I've blown things up. Things have really gone south. But that's all part of the process. And don't be afraid to uh, just see what happens and play around with stuff. And it doesn't have to work the first time. It's not going to work the first time. And if you have an idea of what you're interested in to begin with, I think there's a lot of resources now that there's a lot of tools and things that you can really do it yourself and reach out to, in the community. And, you know, you can work up in steps. If you're really interested in building a thruster, but you have no idea where to start, you don't have to try doing it all at once. Just start looking, um, online. What I do, how I start all my developments is, I Google in the thruster, pulse plasma thruster, Hall thruster in Google Images, and I just look at all the pictures, and I just keep look at as many pictures as I can of the technology, and I, look up, papers and stuff just to kind of get an idea of the general aspects, and Wikipedia articles and everything. But a lot of it just starts at just looking at, what does this stuff look like? What is, the general concepts behind it? And then, you know, how can I take these concepts and principles and start, doing yourself? And I know it's kind of hard because I've gotten into the mentality where, I can just look at something and pick it up and like, oh, I'm going to design it like this. And, I've gotten quite fast and quite good at being able to, just looking at any of the propulsion systems and start working on them. But I think, you can start in stages and, start with something really, really simple and, really basic. If there's, like the how like what I like to suggest for people interested in electrical propulsion is looking at some of the simpler systems like pulse plasma thrusters or vacuum arc thrusters, because the electronics are super simple, and it's something that you can like build really easily and just test on the bench just to see get it working. A little high voltage generator, a little transformer to make pulses, or just little scrap pieces of metal you bolt together, and just start playing around with it and just have fun with it. I think the thing is, the ultimate takeaway is, don't be afraid to just start playing with stuff and failing and just getting your hands dirty, because I think that's where all my experience is from, is just tinkering on the bench. And I'm an engineer by trade. Math is my absolute worst subject. I can't do any calculations. Even for my thrusters, I don't do any math or calculations beyond the basic stuff. It's all just experimenting and finding out and just seeing what happens. So I just say, just work with your hands and play with stuff, and just start exploring things, and then over time you kind of build up the skills and resources necessary to move forward and advance if you really want to.
Excellent, excellent. Well, I love that ethos, and I'm sure that's a good place to wrap it there. Um, Again, thank you so much for making the time. This has been excellent.
Yeah, no, thank you very much for having me. It's I think the series and stuff that you're doing to help bring space to a larger audience, and to every day is really cool.
Well, thank you, Michael. And with that, I'm going to stop the recording.